So, ladies and gentlemen, we can start. Um, if you can hear me, say yes so that I will know you are hearing me. Say yes. Okay. So, if you can see, we have a lot of questions here to solve. Have about 60 questions. Please say yes if you can hear me. So, okay, okay. So we'll start right away. We'll start right away. We have about 60 questions to look at. So, based on the curriculum, question one, 2-point charges Q1. Please, can you see the screen? Can you see the questions on the screen? Can you see the screen? Can you see the questions on the screen? So if you can see the question, let me know. These are the questions we'll be looking at. There are about 60 of them. And by the time you, okay. So we'll be looking at the questions and from there, we'll see how far we can go. Then question one, 2-point charges Q1 equal to 2 microcoulomb, Q2 equal to 3 microcoulomb are placed 0.5 cm apart in a vacuum. Find the force between them. A, 21.6 Newton, B 216 Newton, C 2160 Newton. So the solution is there. The solution is there. The formula is F equal to K Q1 Q2 all over R square. I will know that K is a constant. The value is 9 times 10 raised to power 9. So if you substitute those values in the formula, what you now have is F equal to 216 Newton. So like I always say, the options are always very close. You see, A is 21.6 Newton, B 216 Newton, C 2160 Newton. So you need to be very, very careful. Need to be very, very careful. So if you use your calculator for the formula to calculate that is the Coulomb's law. The Coulomb's law, F is equal to K Q1 Q2 over R square. So Q1 is given, Q2 is given. So if you substitute, you have that. So the correct answer is 216 Newton. Question 2. Two forces. Two forces. The force between two charges is 80 Newton. If the distance between them is double, the new force is A 20 Newton, B 40 Newton, C 160 Newton. So look at the formula. F prime is equal to F all over R square, and R is double. If it is doubled, that is 2 squared, and you have 80 all over 4, and that will give us 20 Newton. So the correct answer is 20 Newton. Number 3, a charge of 5 Coulomb passes through a conductor in 2 seconds. Find the current. We know that current is charge per unit time, and we are not seeing it clear. But somebody is saying we are not seeing it clear. Maybe it's the network from your end. Here is very clear. But if you can hear me, later I will drop these questions on the platform so that you can go through them. But I just want to do a brief explanation so that you can flow. So the questions will be here on the platform, and then you can go through them. So number 3, a charge of 5 Coulomb passes through a conductor in 2 seconds. Find the current A 2.5 ampere, B 5 ampere, and C is 10 ampere. We know the formula for calculating the current is charge over time, and the charge here is 5 Coulomb, time is 2 seconds. So if you divide that, you have 2.5 ampere, and the correct answer is A. And the correct answer is A. Then number 4, 2 charges plus 10 microcoulomb each are separated by 0.2 meters. Find the force. So A 22.5 Newton, B 225 Newton, and C 450 Newton. See the formula for Coulomb's law. F is equal to K Q1 Q2 over R square. Remember that K is a constant. The value will already be provided. So if you now substitute, you have 22.5 Newton. So the correct answer is A. Number 5, an object has a net charge of 4.8 times 10 raised to power minus 19 Coulomb. How many electrons has it lost? A, 1, B, 2, C, 3. So the number of electrons, the formula is N equal to Q over E. And Q is given, E is the electronic charge. It is also given. It's a constant. So by the time you do that, you have 3, and the correct answer is C. The correct answer is C. So we are moving on to question 6. Question 6 says the SI unit of permittivity of free space is A, C square per Newton meters square, B, meter square per a Coulomb square, and C, a Coulomb per meter square. So looking at this, from the solution, the Coulomb's law, F is equal to 1 all over 4 pi E naught Q1 Q2 all over R square. Remember, the whole of 1 all over 4 pi E naught is what we call the constant. So by the time you make permittivity the subject, by the time we make permittivity the subject of the formula, we now have A as the correct answer. So you can see the solution is there. Then number 7, the force between two charges is F. If each charge is double and the distance is half, the Newton's force is A, 16F, B, 8F, C, 4F. So looking at the solution from the Coulomb's distance, we have Q1, Q2, and in this case, we have 2Q, and by the time you substitute the formula, you have, and evaluate, you have 16F, and then the answer is 16F. So number 8, which of the following is a correct property of a charge? A, charge is quantized. B, charge is continuous. C, charge has a mass. The solution, the charge appears in discrete packets or multiple of electron charge. So the answer is A, charge is quantized. Number 9, a 2 microcoulomb charge is placed in an electric field of 3 times 10 raised to power 5 Newton per Coulomb. Find the force. Look at the formula. Formula is important. F is equal to QE. So all the parameters are given. So if you substitute that, you have 0.6 Newton. So the correct answer is B. That is number 9. That is number 9. So number 10. Number 10. A charge of 12 microfarads, a charge of 12 Coulomb flows through a conductor in 3 seconds. Find the number of electron transfer. We have already used this formula. N is equal to Q over E. The N is the number of electrons, Q is the charge, and E is the electronic charge. E is a constant and will always be provided. So if you substitute that, you have 7.5 times 10 raised to power 19, and the correct answer is B. Number 11, which of the following is the property of electric charge? A, charge is continuous. B, charge is quantized. C, charge has no conservation law. The solution is charge exists in discrete packets and it is quantized. So the correct answer is B. The correct answer is B. That is number 11. Then 12. Number 12. Look at it. When a glass rod is rubbed with a silk, the rod becomes A. Negatively charged, B. Positively charged, C. Neutral. Take that again. When a glass rod is rubbed with silk, the rod becomes A. Negatively charged, B. I take that again. When the glass rod is rubbed with a silk, the rod becomes A. Negatively charged, B. Positively charged, C. Neutral. So the solution is electron transfer from glass to silk. The rod loses electrons and become positive. So the answer is positively charged, B. Number 13, a body has a charge of this 4.8 times 10 raised to power minus 19 Coulomb. How many electrons has it lost? So you have that N equal to Q over E. So Q stands for the charge, E the electronic charge. So the answer is 3. Which of the following is not a method of charging a body? A. A conductor, conduction. B. Induction. C. Radiation. Number 14. Which of the following is not a method of charging a body? Which of the following is not a method of charging a body? A. By conduction. B. By induction. C. By radiation. Solution here is that charge transfer occur by conduction or induction and not by radiation. So the answer is C. The question says which of the following is not. So you cannot charge a body by radiation. So the answer is C. Number 15. 2-point charges Q1, 2 microcoulomb, Q2, 6 microcoulomb are placed 0.3 meters apart. Find the force. We have solved a similar this. The formula is F equal to K, and that K is 1 over 4 pi E naught, Q1, Q2 all over R squared. So by the time you substitute that, we have our answer. That is question 15. That is question 15. And our answer will be 120 Newton. So we're moving to question 16. 16, sorry. Question 16. Two like charges repel each other with a force of 100 Newton. Two like charges repel each other with a force of 100 Newton when placed 20 centimeters apart. What will be the force if the distance is increased by 40 cm? You know, the initial distance was 20, and if it's increased by 40 cm. But remember, these distances are given in cm, so we need to convert to centimeters. And you know how to do this. Converting from cm to meters, you divide. So, and the formula is F prime equal to F all over R prime. And by the time you do that, you have 25 newtons. Number 17, which of the following is true about conservation of charge? A. Charge can be created nor destroyed. B. Charge is always conserved in an isolated system. C. Positive charge is conserved but negative is not. That is number 17. We're on number 17. We are on number 17. And the question reads, I take that question again. Which of the following is true about conservation of a charge? A. Charge can be created, not destroyed. B. Charge is always conserved in an isolated system. C. Positive charge is conserved, but negative is not. So the solution here is total charge in an isolated system always remain constant. So the answer is B. So we have solved these similar questions up to 18. 18. Two charges of plus 5 microcoulomb. I mind the force between them. So we also use Coulomb's law. F is equal to K, Q1, Q2, all over R square. And the time we will substitute that. Remember, K is a constant, has a value of 9 times 10 raised to the power 9. So by the time you substitute, you have 135 Newton. Number 19. Please, if there's anything that you want to know or you are confused, drop your comment in the chat box. A charge of 2 coulomb passes through a conductor in 4 seconds. The current is A, 0.2 ampere, B, 0.5 ampere, C, 2 ampere. You know that current is Q over T. I is equal to Q over T, and the charge is 2, time is 4. So by the time we divide 2 by 4, we'll have 0.5 ampere. I have 0.5 ampere. So question 20. Question 20. The force between two charges is F. If both charges are double and the distance between them is also double, the new force is A, F, B, 2F, C, 4F. So looking at this, we have 2Q all over 2R squared. So by the time you substitute, multiply 2Q by 2Q, have 4Q squared. Square 2R, have 4R squared. So that will give us F as A being the answer. As A being the answer. That is question number 20. Question number 20. So we'll move to 21. Move to 21. We'll move to 21. The SI unit of electric field is A, Newton per Coulomb, B, joules per Coulomb, C, Coulomb per meter square. Electric field is force per unit charge. Force is Newton, charge is Coulomb. So the answer is Newton per Coulomb, which is A. The answer is Newton per Coulomb, which is A. 22. A point charge of 2 microcoulomb is placed at a distance of 0.5 meters. Find the electric field at that point. The electric field E is equal to K, which is a constant Q over R squared. So by the time you substitute that, you have 72 as the answer. Don't worry, just listen. I'm going to drop these documents on the distance. So just listen and understand. So we'll look at 24. 24. 24. A charge of 4 coulomb is placed in a potential of 12 volts. What is the potential energy? U is equal to QV. That is the formula for the potential energy. And Q is given and V is given. So by the time you multiply that, you have 47 joules. Always know the formula, substitutes, and get the right answer with the right units. So the answer is B, 48 joules. Number 25. Gauss' law states that the total electric flux through a closed surface is proportional to A, charge enclosed, B, electric potential, C, electric field at infinity. I'll take that again. Gauss's law states that the total electric flux through a closed surface is proportional to A, charge enclosed, B, electric potential, C, electric field at infinity. A, the answer is charge enclosed. 26. A sphere enclosed a charge of 2 microcoulomb. Using Gauss's law, what is the electric flux? That is number 26. Number 26. Number 26. Number 26. A sphere encloses a charge of 2 microcoulomb. Using Gauss's law, what is the electric flux? A, B, and C. So looking at the solution, phi is equal to Q over permittivity. That's the formula. Phi is equal to Q over permittivity. Q is given, permittivity is a constant, and you always be provided. So if you substitute that, you have 2.26 times 10 raised to the power 5. And the correct answer is C. 27. 27. Capacitance depends on A, plate's area and separation distance, B, resistance of the wire, C, voltage across the capacitor. I repeat that question again. Capacitance depends on A, plate's area and separation distance, B, resistance of the wire, C, voltage across the capacitor. A is plate's area and the separation distance. That is the correct answer. 28. A parallel plate capacitor has a plate's area of 0.01 meters square, separation 1 millimeter, dielectric constant is 2. Find the capacitance. Look at the formula. C is equal to permittivity K A over D. I told that permittivity is the constant and the value will always be provided. The A, that is the area, is given, and the D is the separation is also given. So by the time you substitute that, you have the 1.77 times 10 raised to the power 10 farad, and the answer is A. 29. 29. The dipole moment P of two charges plus Q minus Q separated by a distance 2A is A, B, C. So the correct answer is B, 2QA. 30. The energy stored in the capacitor of capacitance 10 microfarads charge to V equal to 100 volts. The energy stored is half CV squared. The C is the capacitance and the V is the potential difference. So by the time you substitute that, we have 0.05 joules. 31. Which material is a good insulator? Which material is a good insulator? A. Copper. B. Silver. C. Glass. You know what is an insulator? Insulator is that material that cannot conduct electricity. So the question is, which material is a good insulator? Copper. Copper conducts. C. B. Silver. Silver conduct. The only thing that cannot conduct is glass. So the correct answer is C. Glass. Number 32. A current of 3 ampere flows for 2 minutes. How much charge passes through it? That's number 31. A current 32, sorry. A current of 3 ampere flows for 2 minutes. How much charge passes? The formula is Q is equal to IT, or you can say I is equal to Q over T. But what we are looking for is charge. So if you make Q the subject, Q is equal to IT, I is 3 ampere, and the time is 2 minutes. But minute is not the standard unit. So if you convert 2 minutes to second, that will give you 120 seconds. So if you multiply 30 by 120, will give us 360 Coulomb. So the correct answer is B. The correct answer is B. Number 33, Ohm's law states that V is equal to IR, B, V is equal to I over R, C, I is equal to VR. We know that Ohm's law is said that the current passing through a conductor is directly proportional to its potential difference. So V is equal to IR, which is the correct answer. Number 34, a resistor of 20 ohm carries a current of 2 ampere. Find the voltage across it. So if you use that Ohm's law, look at the solution. V is equal to IR, and V is what we are looking for. They say find the voltage across. So V is equal to 2 times 20. That will give us 40 volts. And the correct answer is C. Always know the formula, apply it correctly, and get the right answer. That is number 34. And 35, in a series circle, R1 is equal to 4 ohm, R2 is equal to 6 ohm. Find the equivalent resistance. What is another name for equivalent resistance? Total resistance. When resistors are connected in series, you simply add. So look at the solution. R equivalent is equal to R1 plus R2, which is equal to 4 plus 6 will give us 10 ohm, which is the A being the correct answer. Number 36, in a parallel circuit, R1 is 6 ohm, R2 is 3 ohm. Find the equivalent resistance. They are connected in parallel, and look at the formula. 1 over R equivalent is equal to 1 over R1 plus 1 over R2. So we'll take the LCM of 3 and 6 is 6. So by the time you do that, you have 1 over 2, and making R equivalent the subject, you have 2 ohms. You have 2 ohms. So we move on to number 37. Magnetic field around a current carrying conductor is given by A. Ampere's law, B. Biot-Savart law, C. Ohm's law. The correct answer is B. Biot-Savart law. Take that question again. The magnetic field around a current carrying conductor is given by A. Ampere's law, B. By Savart law, C. Ohm's law. The correct answer is B. By Savart law. Number 38. A wire carries 5 ampere. Find the magnetic field at 0.1 meter from it. Look at the formula. B is equal to mu naught I all over 2 pi r. And we have 4 pi times 10 raised to the power minus 7 times 5 divided by 2 pi times 0.1. So if you evaluate that, you have 1 times 10 raised to the power minus 5 Tesla. That T is Tesla. So the correct answer is A. The correct answer is A. 39. Lorentz force on a charge Q moving with a velocity v in the magnetic field B is A. QVB, B. QEB, C. QB over V. The correct answer is A. QVB. That is the Lorentz force. F is equal to QVB. Number 40. Number 40. Number 40. A proton of charge 1.6 times 10 raised to the power minus 19 Coulomb moves at 2 times 10 raised to the power 6 meters per second perpendicular to the magnetic field of 0.1 Tesla. Find the force. Look at the formula. That is the Lorentz force. F is equal to QVB. Q is given, that is the electronic charge. Then the velocity is given, and then the magnetic field is given. So by the time you multiply that, you have 3.2 times 10 raised to the power minus 4 Newton. So let's look at the magnetic dipole. Magnetic dipole moment is defined as A, 1 ampere, B, 1 IR, and C, IV. The magnetic dipole is M equal to I times A, and A is the correct answer. 42. The current loop of radius 0.1 carries current 5 ampere. Find the magnetic dipole moment. Already we have started the formula. M is equal to IA, and by the time you substitute that, you have 0.157 AM square. So let's look at the torque on the dipole in a uniform field is maximum when A, the dipole is parallel to the field, B, the dipole is perpendicular to the field, C, the dipole is anti-parallel. The correct answer is B, dipole is perpendicular to the field. So can the dielectric 44, the capacitance increases when the dielectric is inserted because A, permittivity increases, B, voltage increases, C, resistance increases. The correct answer is A, when permittivity increases. 45. A parallel plate capacitor has a capacitor of 10 picofarad. Inserting a dielectric of K equal to 5 makes capacitance A 50 picofarad, B 2 picofarad, C 5 picofarad. So we have C prime equal to Kc, and that will give us 50 picofarad. So let's look at the energy in the magnetic field. The energy in the magnetic field. which is the question 46. Question 46. Question 46. Energy in the magnetic field. The energy in the magnetic field, the energy density in the magnetic field is A, 1 over 2, that's B, that's C, that's. The correct answer is B square all over 2 mu naughts. 47. A solenoid of length 0.5 meters, 1000 tons, current 2 ampere. Find the energy stored in the field. So the formula is given there, B is equal to mu naught Ni. So by the time you substitute that, you have 0.1 joule, which is C. Electromotive force and induction. What is Faraday's law? What did the Faraday's law says or states? What is Faraday's law? Another, Faraday is the father of electricity. So that is 48. Faraday's law states that the induced EMF is proportional to A, current, B, rate of change of flux, C, resistance. The answer is B, the rate of change of flux. And 49, a coil has 100 tons. Flux changes by 0.05 Weber in 0.1 second. Find the EMF. And the formula is stated here. E is equal to minus N. N is the number of tons, phi all over change of time. So by the time you substitute that, you have 50 volts, which is A. 50. Lenz's law signifies A, conservation of charge, B, conservation of energy, C, conservation of momentum. Lenz's law signifies B, conservation of energy. And 51. Self-inductance depends on A, resistance only, B, magnetic flux per current, C, voltage per resistance. It depends only on magnetic flux per current, which is the correct answer. And 52, a coil has L equal to 0.5 H, current 0.2 ampere in 0.1 second. Find the EMF. And that is the formula, E is equal to L over change over I over T. And L is given as 0.5, I is given as 2, and T is 0.1. So if you use your calculator well, you have 10 volts. And the correct answer is B. 53. Mutual inductance unit is A, Henry, B, Tesla, C, Weber. Mutual inductance unit is A, Henry, B, Tesla, C, Weber. A is Henry. Henry is the unit of inductance. So let's look at the transformer. The transformer has turns ratio. Primary, number of turns in the primary, and number of turns in the secondary. 10:1. It is A, step up, B, step down, C, auto transformer. The answer is B. The reason is that when the number of turns in the primary is more than the number of turns in the secondary, it's a step down. But when the number of turns in the secondary is more than the number of turns in the primary, it becomes a step up transformer. So that's the reason why it is B. 55. If input voltage is 220 volts, If input voltage is 220 volts, turns ratio is 20:1. Once you see 20:1, number of turns in the primary is 20, in the secondary is 1. So output voltage becomes what? And see the formula. And by the time you do that, you have 11 volts. Whereas the input is 220, the output is 11. So we are talking about a step down transformer. So the correct answer is B. So we'll move to page question 56. Move to question 56. 56. We'll look at the Maxwell's equations. Which law is modified to include displacement current? A. Ampere's law. B. Gauss's law. C. Faraday's law. Which law is modified to include displacement current? A is Ampere's law, which is the correct answer. Number 57. Maxwell's equation unifies A. Mechanics and thermodynamics. B. Electricity and magnetism. C. Quantum and relativity. It unifies electricity and magnetism. Maxwell's equation. So next we'll look at 58. 58. Look at 58. In a LC circuit, L stands for inductance, C stands for capacitance. So when you say in an LC circuit, oscillation occurs due to exchange between A. Kinetic and potential energy, B. Electric and magnetic energy, C. Current and resistance. The answer is B. Electric and magnetic energy. And 59. Frequency of oscillation in LC, that is the inductance capacitance circuit, is A. 1 over 2 pi square root of LC, B. 1 over LC, C. Pi square root of LC. The answer is A. 1 over 2 pi square root of LC. Number 60. Number 60. Number 60. Voltage across inductor leads current by, take that again, voltage across inductor leads current by A 90, B 180, C 0 degrees. It leads currents by 90 degrees. That is what we talk about the phase. 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 So the correct answer is A. Question 62. Voltage across capacitor lags current by A 0 degrees, B 90 degrees, C 180 degrees. The answer is B. Know the voltage in an AC circuit. Voltage current always leads by 90, voltage lags by 90 degrees. That is when we talk about the phase. So the answer is B. 63. Reactance of inductor is XL equal to omega L. B. XL equal to 1 over omega L. C. XL is equal to R over C. The correct answer is A. XL equal to omega L. And 64. Reactance of a capacitor is XC equal to omega C. B. XC equal to 1 over omega C. Xc equal to 1 over omega C. So the correct answer is B. And that follows by the question 65. Question 65. Question 65. An inductor L is equal to 0.1 Henry, frequency is 50 Hz. Find the reactance. So look at the formula XL equal to 2 pi FL. And at the time you substitute, I have 31.4 ohms. Then a capacitance C equal to 100 microfarads, F is equal to 50 Hz. Find the reactance. Look at the formula Xc equal to 1 over 2 pi Fc ohms. Then 67, impedance in the RLC circuit. What is RLC circuit? When these three elements are connected in series, what happened? And that is the formula. A is equal to that, B is equal to that, and C is equal to that. So correct answer is the square root of R squared plus XL minus XC all squared. That is the total reactance, and that's what we call the impedance. If it is in the one component, we call it resistance. If it is a resistor, we'll call it resistor. If it is in the inductor, we'll call it inductance. If it's the capacitor, we'll call it capacitance. But if it's happening for all the three of them, we call it impedance. So the answer is A. 68. Power factor in AC circuit is A cos phi, B sin phi, C tan phi. The answer is A cos phi. A cos phi. Then 69. In a pure resistor AC, in a pure resistor AC circuit, power factor is A 0, B 1, C 0.5. The correct answer is B 1. And 70, which is the not last but not the least. In a series circuit, R is equal to 10 ohms, L is equal to 0.1 Henry, F is equal to 50 Hz. Find the impedance. That is the total reactance. So look at the solution. Z is equal to this, R square root of R square plus the L square, and XL is already calculated to be 31.4. By the time you take the square root of that, you have 33 ohms, and the correct answer is A. So these are the questions that we'll have. So at the end of this, I will drop these questions. You can also go through them and see what you can do. So if there's any question, you can drop in the chat box so that we can attend to it now before we leave. So I'm waiting if you have any. I'm waiting if you have any, drop in the chat box before we end the live stream. Before we end the live stream. Is there any problem? I'm still waiting for your ask your questions, please. Ask your questions. Ask your questions. So if I assume you don't have any, so we are ending the revision.